Project 44 is the official sponsor of the Innovation Theater at Edge 23. We thank Project 44 for their continued support of CSCMP.
I'd like to thank everyone for coming. My name is Rich Kilmer. I'm the CEO and founder of CargoSense. Our booth is right there. Today I'm going to be talking about two different ideas, digital twins and digital agents, with a goal towards simplifying supply chain operations. This is our kind of company's mission statement, but I think it's a mission statement we can all kind of agree with. But what we aim to do with both what we do, but also when we work with our customers, is work to simplify supply chain operations, broadly speaking, through a combination of three things: measurement, automation, and collaboration. And these build on one another. I highlight automation here because automation is an important aspect of how we can streamline our operations and simplify them, but it has to be based on reliable information, right? So measurement is a necessary precondition to automation. And you have to have very reliable measurement. You don't want to automate on bad data, right? That'd be the worst thing you could do. And then lastly, collaboration. So supply chains are chains, and collaboration is a necessary part of that. So getting the right people involved at the right time is another important aspect. We at CargoSense have developed what we call a visibility operating system. And this operating system, the goal of it, if you will, the ROI of it, is to reduce workloads of folks in a lot of the very low-level tasks that they perform every day. So imagine from the logistics perspective, having to check on shipments to make sure that they're advancing, right? Works great if you have one shipment. If you have 1,000 simultaneous shipments, it doesn't work well at all, right? You don't have enough people to do that. So most of the time, we just wait for the call on the logistics team, wait for the call of something going bad, and then you're reactive. So trying to reduce the amount of workloads of staff so that they can focus on higher level things, by the way. Secondly, to be able to create very clear service provider accountability by being able to gather data in such a way that you can provide very good KPIs and scorecards. The next one is exception-based tools. We cannot manage everything all the time except through exceptions. And there was a great post somebody said on LinkedIn, I think I read, that said, you can't truly build exception-based systems unless you have a very, very detailed plan so that you know when things are in exception. And we agree, but that's what you need. We'll talk about that a little bit. But then also improving quality. If you have things that are automating things, you're going to have a higher quality system because that automation is running continuously versus people that are going to have different levels of focus in and out of things. So you get a more consistency and improve continuity in the event of staff turnover. We work with major corporations around the world as customers. When we're working with them, they have two concerns. First, the one is they're going to burn their people out and they're going to lose them. The second is what happens when we do lose them. If that person that I had on my staff was our expert with using UPS network, what happens when they leave? And how we're using that particular service provider. When we think of automating operations, a lot of folks think of this as a means of reducing headcount. So you think of automation, we're going to remove headcount. But I think we need to broaden our perspective on this. We need to not think of it merely as reducing headcount, but how to operationalize data. Automation on top of data lets you operationalize that data, use the data you're collecting. We hear a lot of things about visibility systems. Automating on top of visibility data allows us to use that data and not just collect it. To reduce the workloads, as I said before, to boost that operational continuity and to retain talent. I think it was, there were several speakers here today who talked about talent retention and how can we do this. And every conference we've been to in the pharmaceutical space and other markets, talent retention and how do we retain talent really can come down to burning people out. How do we prevent people from burning out of what they're doing and feeling like they're being fulfilled in what they do? The framework that we've come to solve this problem include these two things: a digital twin and digital agents. Digital twin is a loaded term. It's like visibility, right? So visibility, everybody has, it's like the elephant, and everyone's touching the elephant in a different way. Is it the tail? Is it the, the head, the trunk? All these different things. We're all looking at this from different angles. Digital twins are like that. NVIDIA, as the graphics company, right, and the one that is powering today all these technologies around AI, right? So the ChatGPT runs on NVIDIA processors, right, in the cloud. NVIDIA concept of a digital twin is to simulate a warehouse in 3 dimensions, train robotic systems in the simulated environment so that you could load those trained sets into physical robots in the physical warehouse. Pretty cool stuff. But I think that's an amazing idea of a digital twin. It's a true digital 3D replica of, say, a warehouse of the future. What I'm saying here as a digital twin is a bringing together of data about a thing so that you can automate on it, or so that you can solve some problem with that. It doesn't have to be this lofty ideal of building a 3-dimensional simulated thing. A digital twin is just, in my definition, bringing together all the information so that you can do something with it. Why bringing it together? Automating across multiple systems concurrently is extremely difficult. I'm a software background. I still write software. I love writing software, but as much of my company still tells me I shouldn't. But anyway, I love writing software. But in that, trying to automate across different systems that may have different levels of access control and everything else is very difficult. So bringing that together in one place is the foundation for us of a digital twin. We'll talk about what digital twins could be a digital twin of in a second, but just know that a digital twin to us is bringing it together in one place. The next thing is to create software automations, we call them agents, to be able to delegate work to. And the reason we call them agents and not just like software is because you are delegating tasks to them. And the essence of the term agent is agency, right? An agent has a certain set of behaviors and goals and what it's going to achieve for you. We're used to doing that with people. We delegate to folks, can you please do this for me? They do that for you. So digital agents are software that has a specific purpose. The specific thing is trying to do on top of that digital twin. So let's talk a little bit about what could be a digital twin, or the things in supply chain that we can build digital twins of. So we think of freight or parcels, right? The freight itself, we could build a digital twin of that freight. That could be the dimensional size of it, what's in it, maybe certain kinds of requirements of that freight, temperature requirements. Let's say it's a pharmaceutical product that has very strict temperature controls. On the parcel, it could be exactly the same thing. What is in the parcel? Maybe what carrier is moving that parcel? So all of that information about that freight or about that parcel can be brought together in a digital twin about that thing. A warehouse has certain capabilities in that warehouse. It has storage capabilities. It might have, again, we deal a lot with pharmaceuticals. I use these often. But they may have secure areas, cages, right, where secure product goes. They could have temperature-controlled areas where temperature-controlled product goes. So a warehouse could also have digital twins of those things. And then next, orders. An order isn't a physical thing. An order is a logical thing. We place an order between one company and another. But the digital twin of that order is the item being ordered, maybe the terms of that, terms of delivery, right? Any kind of SLA requirements around the delivery of when that order needs to be fulfilled. A shipment is usually against an order, right? So if we think of like an ERP system, a shipment can come in and fulfill parts of an order. An order isn't totally fulfilled. It comes in over time, but a shipment may have things like a master airway bill, other types of tracking information around a shipment. And then we talk about packaging. I mean, Shep's over here. They've got, plastic or wooden pallets, right? Any kind of intermediate bulk container, it could be a bin or a pallet. We can have digital twins of those. So in other words, so imagine this notion of I've got a pallet and I load my product on that pallet, and that's my freight. The life cycle of that pallet is a different life cycle than the life cycle of that shipment of that freight. Each of those have different digital twins. They have different pieces of information which is important to them. On the pallet side, what are you doing with those assets? You're trying to manage the pallet pool, make sure that you have enough pallets at certain origins so they can ship out at the consignee, the destinations, and then recover those when a certain number appear, recover those. In any kind of asset, you want to make sure that you don't have idle aging, that you equally use all of your assets in a certain class of asset. That's what happens with the pallet. So the digital twin of that pallet is actually holding the data around the use of the pallet as a thing, as it moves from one place to another and then back. The freight on top of that has a different digital twin, which in parallel is being built up around the requirements of that freight in a shipment, which is going against an order. And you see that all these things effectively tie together. But each is their own unique digital twin that represents the information about that thing. The sources of that information, there's a lot of different sources of that information. You can have ERP systems, you can have TMS systems, you can have WMS systems, you can have all these three-letter acronyms of the 3PL data sets, visibility platforms, sensors, IoT devices that are actually on that product that are telling us what the current temperatures of that product is or where that product is as it's moving through a shipment, for example. All of that data needs to be pulled together so that you can do the next step, which we'll get to, which is automate on top of it. And this gets us to that, which is digital agents. So digital agent is, again, just like digital twin, it's a conception around a piece of software which has a specific process it's responsible for. I'll give some concrete examples, and I'm going to actually demo some stuff that'll show it and hopefully make it a little more concrete. But the first thing is, what is the agent responsible to do? I use the example of a pharmaceutical product that moves, right, through a supply chain. And let's say that pharmaceutical product, when it gets to an airport, the airline's responsibility is to store that in a refrigerated room in that warehouse. So you book a pharma rate. You're expecting your temperature on the outside of that pallet to go within a certain temperature condition, which means it's in that room. Say it's a 2 to 8 refrigerated room. Did the temperature on the outside of the pallets drop after it got to that location? That's what the agent's job is to do. It's checking the temperature. Once it arrives, it knows it arrived. Why? Because of geofence. So it knows that it's arrived. So the agent first is observing to make sure it's getting to these different milestones. Once at this milestone, it's saying, I've got environmental constraints. Is that environmental constraint being met? We're doing that at scale for DHL and all their pharmaceutical shipments they ship for all the pharmaceutical companies in the world. So these agents' job is, instead of a human having to call the airline to say, is it in your cold room, the IoT device on that pallet is giving you temperature. That temperature is being relayed into the digital twin for those pallets, right, those shipments of product. And then that is going against the constraint to say, yep, it's within 2 to 8. So I know that this is okay. That part of the SOP is being complied with, right, for that particular shipment. So that's the process it's responsible for. And remember, these agents can be responsible, especially in shipments, for handling process after handling process after handling process, right? There's a sequence of them. And then next, what is the behavior of that agent? What do you do if that's violated, right? So it sees the temperature condition is not met. That agent could raise an exception. And an exception becomes its own digital twin, because there's a life cycle to an exception, such as the temperature conditions are not being maintained for my pallet by, I'm not going to pick on United, but I'll just say United's, because I fly out of Dulles Airport on United all the time. United's IAD warehouse, the temperature of my product is not within 2 to 8. It's not in that room. What do? You raise an exception, and you want the temperature to come back down. The agent could automatically make sure the temperature comes back down. You could have another agent that actually emailed that warehouse for United and said, this particular product is supposed to be stored at this particular temperature. It's not currently. Please have somebody do this. And how do we know what happened? The temperature goes down. But if it doesn't happen, it can elevate it to a human. So one of the things about digital agents is their behaviors and what they can drive, right? What the agent drives eventually is going to get a human involved. But it gets a human involved at the right time and gets pulled into the platform at that time to resolve an issue with all the context necessary for them to act. And that's important because what we're trying to do is to say all of our people in supply chain are very, very busy. We don't live in these tools. We don't live in a visibility platform. We live in the world of managing supply chains and working around supply chains. So how can we streamline this so that people get pulled into the tool at a point when a human needs to act, and then leave the tool, right? That's basically what we're trying to enact here. And that's where digital agents come in and how they get embodied. So I'm going to use this to show a demo of a couple of screens. The first of which is how you define this. So this is an example, at least within our platform, and it's just going to show you a couple of things. I'm just going to point them out. So first, this is a multi-step shipment where it's going to go from origin to, say, Expeditors is a 3PL, the warehouse there near LAX, from that Expeditors 3PL warehouse to the airport, from that airport flying to Dulles, from LAX to Dulles, and then it was going on. And if you keep going, this is going all the way to Ireland. Yeah. So it's progressing along here. And what we're setting here are constraints. We're saying that the transit should be no more than 4 hours. If it arrives later than 4 hours, why? Because we know those distances should only be about 3 hours. It might be a traffic accident that slowed down that, but that has ramifications downstream. So the agent is first looking, the shipment agent is looking to make sure that something is going to get from that origin once it leaves to that destination within 4 hours. It's also checking to see if it's the 15 to 25 truck C is a CRT truck, right? Controlled room temperature truck. So it's not a refrigerated truck like the 2 to 8 C environment. It's a controlled room temperature truck. They want to make sure the temperature conditions of this refrigerated truck are maintained from beginning to end. And of the journey of the truck. And then once it gets to Expeditors, its transit from, it's not giving any time constraints here or any other kinds of constraints while it's at Expeditors. But once it leaves, it should get to the airport within 2 hours. And it's going to delay 30 minutes once it leaves the geofence to start doing temperature analysis of 15 to 25 to let the truck maybe, you know, if you opened the door and it was an open dock, it's going to heat up inside that truck. And then once you close the door, it should cool back down. And so you don't want to falsely alarm. So you can set these delays of, I want to delay 30 minutes before the agent starts looking at the temperature to make sure it's the correct temperature. So this is a way of constraining that. And another important thing is when it's leaving LAX, when it's dwelling at LAX, I have this notion of an airline temperature control tarmac. $35 billion a year in pharmaceutical products are destroyed due to temperature during shipment. The vast majority of those die on a tarmac somewhere, either because it's too hot or too cold. It is an unconstrained environment, right? You can't control the environment of a tarmac. So the way this works with pharmaceuticals is they book airline pharma freight, and that minimizes tarmac exposure. So they'll say, you're not going to be on the tarmac more than an hour and a half. We guarantee it. But the agent verifies that. It's going to get hot or it's going to get very cold, right? Depending on if you're going to be in Chicago in the wintertime, it's going to be very cold. If you're in Dallas in the summertime, it's going to get very hot. But it shouldn't be that hot for that long a period of time. And so that's what that analysis is performing. So the agent is moving back and forth between these analyses. And what I'll show you here is what the agent looks like in our system. So this is an active agent on an active shipment in our system that is analyzing all of these things at the same time. It's making sure that it arrives at its final destination. It's confirming that it gets there. The first one is making sure it arrives at the next milestone. This happens to be the last milestone. But if you had an intermediate milestone, it would have that. Checking that sensors don't drop below 20% battery life. So you're using an IoT device, you want to make sure the battery life doesn't drop below a certain level. What's great here is what happens when any of these are violated is an exception is raised. So the job of this agent is to raise exceptions if any of these happen. Make sure that the light remains less than 175 lumens, which basically means, did somebody open the package? Did they get exposed to light? So it's a lightweight way of thinking of security. Next, making sure that we see data from sensors at least every 24 hours. So somebody hasn't removed the sensor or destroyed the sensor and that sort of thing. And then watching for unplanned dwells longer than 60 hours. This is just a catch-all to make sure something doesn't get stuck. Here, this is actually moving via FedEx LTL. So FedEx's LTL service. And sometimes things just get stuck in a warehouse. And, you know, but if a person's not watching every shipment, you don't know that. And so this catches that. And then lastly, verifying all the sensors are seen together. This particular one actually is a multi-pallet shipment. And so each pallet has its own, there's one anchor sensor and then a whole bunch of other sensors on it. And it makes sure all the pallets are moving together. This is a high security shipment. They don't want to lose it. They don't want to leave a pallet behind. So that's what this catches. So this agent's job is to make sure all of these things are being done every moment it gets data from any sensor. So the last time this updated was an hour ago. So I think it's each hour or each 2 hours, I think once it's dwelling, it's going to send out sensor data. When that sensor data comes in, all of these things are going to be checked. So in transit, every 15 minutes it gets data. So instead of a person checking on these every time, an agent does. And then an agent raises an exception. And for most of these, we have agents then email warehouses. And as a matter of fact, on the battery, if the battery drops below a certain percentage, we have an agent that adjusts the profile of the sensor to extend its battery life. So these agents can work together to be able to solve these problems around here, the digital twin, which is the shipment. So in summary, what we get is by coalescing this information into these digital twins, there was the digital twin of a shipment, which I just showed, and we're delegating these processes to digital agents overseeing that shipment to make sure those constraints are met. It allows us to prevent being drowned in data, right? We as people, from being drowned in data. And it allows us to construct systems that automate tasks with flexibility. Notice what I didn't say is that we do have a strict path that something's going to follow, but we aren't giving it a firm route in which it's following, right on the road. Could do that, but in this instance we don't. And ultimately, the goal of these things is to maintain this kind of operational continuity, increasing quality, maintaining personnel, and preventing burnout of people that end up having to do this on a continuous basis inside of our organizations. So with that, I will open it up to any questions folks have. Anything? All right, well, like I said, our booth is right there with CargoSense, so if you want to talk to us, we're right across the hall. So thank you very much.